Okay, so you want to be following along with this. Remember that this is, we're not strictly doing the textbook exercises, but this is still something that you want to follow along with me so that you can submit the file at the end. I'm not going to be super critical about exactly what you've got in it and so on, but you got to submit something. So do follow along, and that's why it's critical that if you do not have that SQL file downloaded and ready to go, just let me know. I suppose you could always follow the recording later on since we're doing one, but you don't want to have to do that. Okay, so here we are. I'm going to go ahead and open up this script. So here is the little button. And let's see, I got to find that. We're in Unit 7 here. See how organized I am? I have to be or else I'll be in big trouble. There's the Book Trader demo, SQL, open it up. And this is one of those things where it just creates a database and a couple of tables. 3 in fact, and then inserts a bunch of values into this books table. So this is the same demo that I used, I guess, in Unit, I can't remember if it was Unit 5 or it was a recording that I did for Unit 6 for you guys. But either way, same little thing where it's just a collection of kind of like, placeholder values for these books. Just go ahead and hit Control-Shift-Enter to run the whole script. This will create, first dropping it, if it is Book Trader demo, creating the database, and then using it, and then it'll create those tables and add the values in. So it should run the whole thing, Control-Shift-Enter. And hopefully you see nothing but green down here. I'm going to refresh the navigator, and there is the Book Trader demo and the tables, and then I just like to just pop
Is there a
these
file
open.
that we need to download for this one?
Yes, that's what I was talking about just a moment ago. Go on to the classroom stream and download booktraderdemo.sql, please. So I personally just like to crack open all these tables right after they're created just to kind of check them out. I could go to the table inspector. That would actually make more sense. But it's just easy just to kind of go ahead and select the rows even if there isn't anything in them. Books does have something in it, right? Here are these 10 entries for the 10 books with author last name, first name, number of pages, and stock, whatever that means. This is, again, it's just something I found online from one of the data sources. And then the user reading list. This is what I had you guys create for like the user created table that is, will be a subset of the data in the big table. And then users, of course, username, user password, and email address are all varchar 45, which is our old friend. This is not going to work. There are some things that we're going to be changing about 2 of these tables. Now, the thing that we don't want to change, if we can possibly help it, is books. I've tried to impress upon you guys that once this data is assembled, you really don't want to do anything to it unless you decide or you figure out like, oh, wait a minute, there's something wrong with what I've got here. Like I'm actually missing a column, or I've got a column that I thought I was going to need and I know I'm not going to now for my app. Or worst of all, if you look through it and you see, oh, wait a minute, there's some normalization problems here and I better fix that. So other than those things, like once you get your big data set up, just leave it alone. Do not touch, right? This is like it's the untouchable here, right? This is like your source of all knowledge. You don't want to mess with that. But these guys here, we're going to make some changes to it. Users, that's going to be the easy thing. We're going to start by creating a couple of sample users and just putting them in as entries. And we'll see right away that we're going to wind up with a problem with the data types that we've got in here, especially for the user password. The other 2 are okay. The user reading list, this is the one that you're going to be, you guys are going to be a little upset with me about this because I've been misleading you on purpose about getting this table set up. So what I've said to you is that we're going to create this demo like this table, right? That's going to be user reading list. There's not going to be a user called user. This is just kind of our proof of concept thing that we're creating. And then later on, as users are created, they will all create their own tables that are like this one, have the same structure, right? Each one would have the ID, books ID, and user rating this up. So I put a user rating in mine, right? So that's my added functionality. For some of you guys, you're assembling collections to fight each other with MTG cards or whatever it happens to be, right? So it's got the ID for each entry, the book's ID, references, the books table, and then the user rating is something the user adds in this case. So yeah, and I've told you guys yeah, we'll be creating this like the table a whole bunch of times as each user is created. They will have this table created for them where they can put the stuff in there. So that was a lie. This is not a it's not a good way of doing things. So let's talk about that for a second. Let's unpack it. So first of all, um, you need to have some kind of mechanism so that anytime a new entry gets added to, users, right? Anytime a new user gets added to users, it automatically creates a table for them with their name in the title, right? So you can and can't do that in MySQL. Okay, so there's these things called triggers, and they're often confused with events. Events are SQL commands that you set to run at a given time. You put a time, a timestamp on it, and you say, okay, so every Saturday night at midnight, we're going to do a MySQL dump to back up the database, and you can set that up as an event. A trigger, on the other hand, is a script that is set to run when another script runs. So one script runs on a table, and then something else is done. Either another column is, calculated, or something like that, right? And it happens whenever something else. So you could say, okay, so great. So we'll just set up a trigger for this, so that every time a new entry gets added, that this new table gets created with that user's name in the title. But you can't really use triggers for DDL operations. Remember, DDL is data language. Um, so it's the structure language, like creating new tables and so on. And it's not really built up to do that because of the security concerns and so on. So you couldn't really do it directly like that. It wouldn't be possible. Now, what you could do is you could have them as completely different scripts. So, and this would be something that would be run by the admin on the PHP, the node, whatever. So that whenever a new user click on the button that says create account or whatever, it would fire off two completely separate SQL scripts. One of them would enter their values into this users table, and a completely separate one could create a table for them with their name in the title as a variable, right? So you could do it that way. It's possible, but you wouldn't want to. Why? Because it could lead to an absolute monstrosity of a database. I mean, we're talking, okay, so if you had one user named user, okay, maybe this would make sense. But what if you have a dozen, what if you have 100 users? What if your app gets popular and you wind up with 60, 70,000 users all of a sudden? Do you really want to have 60 or 70,000 tables, each one with just a little bit of data in it? Probably not. Like each one, in this little demo of mine, like each one, let's say I actually had a significant number of books in here instead of just 10. Maybe each user's reading list might be up to, I don't know, anywhere between 5 and 50 books, let's say, on average. That's not very much data. And to have that in, 50, 60, 70, 100,000 tables, that would just be entirely messy. I mean, you'd be setting yourself up to data corruption, um, misfiring of data referential integrity, as well as just being redundant as all heck. So we're not going to do it that way. We're not going to. We're going to change things up here. So that's the big one, but we'll tackle that separate. The first thing we do, and I think we can do this before we take a break, is just go ahead and add a couple of users to the users table. So once you guys have yours in place, this is probably the first thing you want to do after you get your data imported and you get your users table built. Let's go ahead and get a couple of users in there. I'm going to do like really, really basic stuff here. So I'm going to make a new SQL tab. And I'm going to do our old friend insert into. Sorry, let me get that a bit bigger. Insert into and users. And you have a couple of different ways of doing this. One, you could say, okay, I'm going to insert username, user password, and email address, and then give it those values and let the ID incrementer do its thing. Or you could just say values and then type in default for ID. It doesn't really matter. It doesn't really matter which one you do. So let's do it the first way this time around. Okay, so I'm going to specify which columns I'm going to be entering here. So I want, I was just looking at it. What is it? Username, user password, and email address. So username, oops, user password. This is one thing that where I kind of named it with an aggregate here instead of just calling it password. Because see what happens when I just name it password? It's showing up in this blue, indicating that maybe this is kind of a reserved keyword in MySQL. And actually, it's a function name. So, I mean, you could always, if you really wanted to call it password, you could always just put quotes or backticks or something around it. That works too. Either way. But anyway, that's why I called it user password, not just password. And then email address, right? So we're going to insert these different values here, and there are the values. And then when we do that, when we specify that these are the different columns that we're inserting into, then we can just kind of ignore the ID, that first column, and it'll auto-increment on its own. So let's do the values here. And I'm going to keep it super simple here. I'm going to call this, let's say user1, and I'm just going to add user1 and user2. And for each one, their password is going to be password, like this. And don't hit Control Enter yet because I'm going to change something about this. Let's see their email address. I'm going to say user1@users.com. Okay, so again, these are just proof of concepts, right? No one would actually have an email address like that. No one surely would be silly enough to use password for a password. Now, the first thing, this chapter 8 is all
You
about.
say that.
Well, I say that, but surely, yeah, you're right. Some people would, but it would be a bad idea too, right? If I were a hacker, that's like the very first thing I would have on my table to try out. And I would be shocked when it actually worked.
It's like when everyone had those briefcases with numbers on them. 1, 2, 3, 4, 5.
Yeah, right. Okay, so let's see. Chapter 8 is about creating not 8, 18 is about creating, users and authentication and so on. But that kind of jives with just using a little bit of salt hashing. Password hashing is, it's not genuine encryption, but it's a good idea to do anyway if you're doing something on an enterprise level where the risk could be catastrophic. If you were hacked, then you'd probably want to hash a password several times over and add some salt. And I don't know if any genuine encrypting would be necessary or advisable, but in this case, we're just going to hash it once and that's it. So the simplest one is MD5, and it's just a function in MySQL. So instead of just typing in password in quotes, you do MD5, and then the one argument is the string that is meant to be hashed. So this is for reasons that, I mean, I'm not a hacker. For reasons I don't really understand, this is not considered to be sufficient any longer. In fact, I guess it's been a while, even though a lot of people still use MD5. I guess it actually is kind of hackable. So SHA2 is the one that's recommended. And this one's a little bit different in that you need two different arguments in here. So first of all, the password to be hashed, which in this case is just calling it password. And then what's the resolution of this? I know there's a better word than that, but are you going to do SHA2 at 128 bits, 256 bits, 512 bits, that sort of thing? And you don't have to remember any of those because SHA256, which you could put in here, right? But just in case you don't remember, there's a default value here. If I type in 0, it'll make it SHA256. So 256 bytes. And this is considered to be, at least by some people, to be sufficient. Other people, if you look on Stack Overflow, they're like, oh God, no, that's not sufficient. You got to do it multiple times and salt it and everything. I don't know, for like a little app, I think it would be fine personally. But like I was saying, if something like a genuine enterprise solution, like if I were building something for, I don't know, Chase Manhattan or something like that, I'd probably want to get a team member to really tackle this seriously. And it wouldn't be me. So user one, SHA2 password at 256 bits, that's the 0, and then user one at users.com. Now I'm going to hit Control Enter here, and I'm going to get an error. Control Enter, And there's my error. Data too long for column user password at row 1 is what it's telling me. And I'm like, what are you talking about? Password? I'm pretty sure that I set a variable character of 50 or 45, right? I should be able to do 45. Let's go ahead and double check it and make sure. So I'm going to users. This time, instead of selecting the rows, I'm going to go ahead and go to the inspector here and look at the columns. And yes, varchar 45, that should be plenty. Well, it's the hashing that does it. When this says 256, what it's talking about is it's hashing this password out so that it's 256 characters long. And so I need to have a different data type before I can do this. So before I can do any insertion at all, we have to do an alter table. Otherwise, it's not going to work. So let me do that above this. I'm actually going to go here and hit return a couple times so we can go up here. And let's do a quick alter table. And we're alter table users, right? And we're going to modify column. And the column that we're modifying is user password. And we're going to make this varchar. Or actually, no, not varchar. This is not variable character. I'm always typing that because that's what you use all the time. But this means this will always be 256 characters. Not that it could be up to 256 characters, but it will be it. So instead of varchar, char. And it's actually 255 because it's 0 to 255. And then not null. And I think that's all we did on that. Mobile, yeah, that's it. So let me check, double check. I call user password, char 255, not null, semicolon, let's run it, control enter, and there we go. And now we should be able to execute this insert into users. Haha, success. Anybody not get success on that one after doing the alter table?
I think I did. Just give me a second.
Sure.
It's got the unknown column, password, and users.
Yeah, it's not password. Call it user password.
I used a different name. Should just change it to. Okay, let me change it.
So were you building Book Trader demo from scratch then? Because in here I've got user password.
Oh, okay. I see what's going on.
Okay, we'll have a chance to look at it because I'm just going to do one more thing and then I'm going to pause the recording and we'll take a 10-minute break here for you guys. So all I'm going to do is I'm going to take this entire block here, I'm going to copy it and I'm going to paste it underneath itself. And let's add another, wow, what just happened? There we go. Let's give another user, just so we've got a couple, right? So this one I'm going to call user 2, see how creative I am. The user 2 also uses the password, and then the email address is going to be user2@users.com. By the way, there are other things that we could have done with this table that I probably should have, but I wasn't really thinking about it at the time. It often happens with me. Email address here, it says not null, but it actually should also have a unique value, right? Or a unique clause, because you always get that, right? If you try to sign up for an account, like forgetting that you already signed up for an account like 5 years ago or something like that, and it tells you, oh, this email address is already taken, you can't use it. That would probably be a good thing to put in here, and I could have just done unique here. I'm not going to mess with that for right now, but I'm just saying there are other things that I probably should have done here. Whoops. And this stuff to think about when you're designing your own database. You think about the functionality and what the users should be able to do, but also what should the users not be able to do. And they should not be able to create another account with the same email address that they used before, right? It should be unique values only. So I just now thought of that when I'm doing this. So yeah, sometimes that happens. So let me just double check this. Username, user password, email address, values. This time it's user2, password, user2, blah, blah, blah. Control enter. Here we are, showing green. Let's go ahead and select users again. I'll close this one, or just run it again, actually. There we go. And there are the two users. Now check out what we've got here. Here's user 1, user 2. The IDs 1 and 2. Here's their two email addresses. And take a look at the hashed password here. So, and then notice that it's the same thing. So this is why you shouldn't pick something like dumb and easy like password, because um, if they know what you're likely to have used, if they can guess it, then they can also hash that password and then use that, right? It's the same thing. So it's not like hackers don't have in a table somewhere the SHA-256 value for password. They do, and it's going to look just like this. And if you use password and they can guess that, oh yeah, they used SHA-256, then they will be able to hack into their account. So don't use password for password. Okay, I'm going to go ahead and pause the record. I'm not going to stop it. I'm going to pause the recording, and it's 8:10. I'll let you guys go on a 10-minute break. I will see you guys in 10 minutes, and we will resume this, and I'll show you what to do about the pesky reading list or collection table. We're going to tackle that next. Okay, awesome. See you guys in 10. I have the recording started up again. And let's talk about this user reading list here. So this is the one that I said we weren't going to be needing and we were going to do something else. So if you want to on yours, you could leave yours alone. If you do, I would take off whatever foreign keys you applied to it, just so it doesn't get in the way, it doesn't entangle anything, because it may enforce that integrity, right? If you then try to change one of the columns in like your main data, and then this table that you're no longer been using starts complaining at you, it might get kind of irritating. So you can keep it if you need it for reference. Otherwise, you can go ahead and just get rid of it. So let's go ahead and it's called user reading list. So I'm going to go ahead and drop that table. Table user reading list. Now when I do that, I'm going to go ahead and it's gone. User reading list, I've still got this open in another tab so we can just see what was in it. So it had an ID, so auto incrementing, no surprise there. It had a books ID. This was the foreign key, so that each time the user added a book to their reading list, this would populate with the ID of the books table. So let's say I wanted to add this Officius book to mine, and then it would enter 6, which is the ID of that in books, and it would put that into the books ID column here for that entry, and then the user rating, which I believe I set to be nullable. Yeah, well, I did say not null. Yeah, I probably should have put a default null on there, but I wasn't thinking of it. But anyway, yeah, and then if there was a user rating, then the user could input it. Otherwise, it would remain null. So that's what this is basically accomplishing, is that I need to be able to add books to my reading list, and then if I've already read them, I want to be able to give them a rating, from 0 to 5 or whatever. So that's what we're trying to do. But what I'm going to have you guys do is think about this in a different way. Remember when we were doing the midterm exam, and I gave you the instructions for the EER diagram, and I said, okay, so each artist can show in multiple galleries, and then each gallery can have multiple artists, right? So one-to-many going one direction, one-to-many going the other direction. That makes a many-to-many relationship. So let's see if maybe that could apply here. So let's ignore the user rating for right now, and let's ignore the ID. Let's just look at books ID and how it references the books table. So here we have a situation where I've got users, and the users are able to add multiple books to their reading list, right? So I could put 5 books on my reading, I could 10, however many that there are on the database table, I could put that many into my reading list. So yeah, each user can have multiple books in their reading list. Also, each book might have multiple users added to their reading list, right? So the same book, what do we call it here? The Officius, right? So more than one, maybe user 1 and user 2 both like Officius and want to put it onto their reading list. So that's one book to many users. At the same time, each user can have many books in their reading list. So one-to-many going one direction, one-to-many going the other direction. This is a many-to-many relationship. We can do this without creating a third table or at all, much less, another third table for each and every user that comes along. We can just create a junction table in here between users and books. And that's all we have to do. It's a many-to-many relationship. And this is something that happens a lot, to where you're thinking, okay, yeah, I need to add all these tables, and it winds up being this complex thing. And sometimes all you need is a junction table fitting the two together. Now, in this case, we are going to have to alter the junction table a little bit beyond what we've seen before. So far, when we did the junction table, the only columns in it were the foreign key columns, right? There was a foreign column key referencing one ID, and another foreign key column referencing a different ID in a different table. You can actually have more columns than that if you want to. It doesn't have to stop there. Now, really, to be called a junction table, properly speaking, I believe it needs to be just the foreign keys, and that's it. But that's okay. We don't have to call it a junction table. We can call it something as the bridge table. We can call it something else. It functions the same way, except that we're going to give it another column. In this case, there's going to be another one for user rating. So in your project, it might be something other than that, like I don't know, condition or something like that, right? If you're doing trading cards and you got to be okay, so I've got this trading card added to my collection, but I have to be able to enter in what condition it's in. Okay, so that would be another possible example of having an extra table in there. So let's go ahead and see what this looks like. I went ahead and dropped my user reading list. Like I said, I'm going to keep this. Let's see, I'll make that open. Let's go make users open here. Well, I'll go ahead and leave this. User reading list, this is the one that I just dropped, but as long as I leave this tab open, I'll still be able to see the structure here in case I need it. So let's go ahead to our SQL tab here, and let's create a table. We're going to create a junction table here. Now, as you guys know, this one is a little bit more complex than just doing it in the EER diagram. The EER diagram, it's just a matter of kind of clicking back and forth between these. By the way, when I switch between tabs, can you guys still see what I'm looking at? Can you see the EER diagram here? From the midterm? Okay, good. I just wanted to make sure. Awesome. Okay, so what was I just saying? So yeah, it's a little more complex when you're coding it, but it's not that bad. And I think you guys have seen the constraint business for long enough at this point. I'll go ahead and do it in the shorthand way, just to make life a little bit easier on us here. So let's create a table. And I'm going to call this users books. MySQL likes to call, not MySQL, but Workbench likes to would probably call this users has books, or books has users, or something like that. I don't personally like that naming convention, as I told you. I think users books makes sense. So we're going to create, and remember, the first thing we're going to do is that compound primary key, each column of which is a foreign key referencing the other two tables that we've got. The other two tables are books and users. Each one of those has an ID column. So I'm going to have users ID, and this is going to be an int, not null. It's going to be referencing the other, like, users ID. And let's go ahead, like I said, I'm going to use the short syntax here. I'm not going to do the whole constraint business. Just go ahead and say references users ID, like this. Short and sweet, right? As long as you don't need to have a constraint with a name on it, this is perfectly fine. So we need another one. And let's call this books ID, since it's going to be referencing the ID column of the books table. This is also int, not null, references, oops. And this time it's going to reference books ID. Now I was saying that in addition to these, you can add another column to this. It may not officially be a junction table anymore, although it might be. I'm not 100% sure about that. But anyway, you can add another one here. It's perfectly fine. So in my case, the other column that's missing is this user rating here. And so I'll just go ahead and add it. Why not? User rating. And I believe I let's take a look at the original SQL script here. Yeah, decimal. So 2 total digits, one of which is after the decimal point. Decimal, oops, 2 and 1. And I think that will do it. Let me just hang on a second. Yeah, you know what? We are going to have to do some more here. I'm glad I stopped before creating this. Remember with the EER diagram when we were doing this, the galleries has artists here that Workbench created for us. And when I hover over primary here, it shows that, you know, it highlights both galleries ID and artist ID, showing that this is a composite primary key. And we actually need to create that here. So it's actually not enough just to put in these columns here and leave it at that. Let's go ahead and do this. So when you're doing a single column as a primary key, like here, you can just put it here in this kind of implicit or inline, I should say, this inline clause here, instead of doing it as a separate clause separated by commas. But if you're doing a composite primary key, you can't do it that way. You have to do it as its own clause. So let's go ahead and take a look at what that looks like. So after giving it the columns list, I'm going to put a column, and this is where, I mean, we've done stuff like this before. After you do the columns list, this is where you would like create a constraint for the foreign key if you were doing it that way, which we're not. But here is where we will do the primary key this time. And what you do is just indicate primary key, and then parentheses, you tell it which columns you want to be part of the composite primary key. And so it's going to be these two columns, users ID and books ID. I'm glad I thought of this because this is good for you guys to see what this looks like. So this will set up the primary key. Now, unlike a normal primary key, when you do a primary key like this as a single column, the uniqueness is enforced. You don't have to say unique on here because it'll just do it. But as far as I recall, it will not do it with this one. So we actually have to add a unique clause down here too. So what we're doing here, remember the whole point of a composite key is when you have two columns, neither one of them needs to be unique on its own, but what needs to be unique is the combination of those two, right? The composite value of those two columns, like invoice ID 1, line item 1, right? There's only one of those. There might be multiple rows that have an invoice ID 1, but there's only one entry in that whole table that has an invoice number of 1 and a line item of 1. So you use the same thing. You tell it which which columns you want to be unique. And what I'm trying to remember right now, I'm trying to remember if we actually need to name this. Let's try it without and see if it complains at us. So I'm just going to name it. I mean, you just give it a name. You can call this, whatever right here. And then in the parentheses, put in two columns that are going to make it up. But I'm curious to see if it will accept this without a name to the uniqueness. So we also need users ID and books ID. And if we do this, unique users ID and books ID, it will make it so that the combination of these two entries in each field, combination of these two fields in each entry will be unique. There will only be that one combination that happens once and only once in that table. Okay, so this has gotten a little more complex than I thought it was going to. Let me double check over this thing. Create table users, books. There's the user's ID. We're doing the simple inline syntax here. References users ID, books ID, references books ID. There's our third, an extra column that isn't really part of the junction. Setting a primary key between these two columns and also unique values between the two columns. Okay, I'm ready to try it.
Could I ask a question?
Yeah, of course.
What happens if a book shares the same name?
Well, that's okay. We haven't set the title to be unique here. So as long as it's got its own ID.
Oh, so the ID. Okay, yeah, I thought the ID you meant the title. Okay.
Yeah, did I say it wrong? If
Are
I,
you telling me?
yeah, if I said it wrong, I meant the ID. The ID is the one that is unique values in this.
No, I don't think you said it. I just assumed.
Okay, all right, cool. So yeah, in this one, ID is the one that's unique, and after that, it can be anything, right? Because we haven't set unique to any of these guys over here. I was saying that the users probably should have had a unique clause for the email address. You don't care if different users have the same password, really, but email address should be unique, but I didn't do that. And then on this one, we want to make it so that the combination of these two is going to be unique. User's ID and books. Books. Ha! Books ID. I should really do more copying and pasting. Okay, I'm going to try it. Boom, it liked it. It thinks it's okay. I'm going to refresh over here. User reading list is going to disappear. I do, and it's going to be users books. Let's go ahead and select here. There's nothing in it yet, but here we go. We just have those 3 columns, and we're good to go. So we can now put in some values here. I'm not going to right now. I think we'll do that on Wednesday, where we'll actually start putting a few test values into our junction table, or I guess I'll call it a bridge table because I'm not sure whether it qualifies as a junction table any longer. But this is, like I said, it's a little more complex to set up, but this is going to be a lot better than adding thousands of tables, like one for each user. This is really, really want to do. And if you wind up with a couple of 100,000 entries in here, well, it's not the end of the world. It's not going to be totally scalable, I think. And if you had something that's truly like, oh my gosh, we've got 1 million users all of a sudden, then yeah, you might need something else in place of this. But for the time being, like getting the app started up, and this is fine. So let's go ahead and take this and let's see what our new EER diagram from this database looks like. So I'm going to close out the model from the midterm exam Redux. As you know, you can only have one open at a time. And I'm going to go to the Home tab, Models, and don't click the plus one, but the little arrow, and create EER model from database. And let's next our way through. So as you know, you have to log in every time you do that. And if you did your password right, it's going to be a pain in the neck every time you have to do it. Next, I'm going to choose Book Trader Demo. Next, next, execute, next, and finish. And why did it not give me? This is not what I was expecting. I was expecting it to show the relationships. What did I do wrong? It's also only showing one column for user's ID. Okay, well, I don't know what went wrong. Don't worry about this part yet. What I was going to have you do is, like once you refactor your database, like I have just here, for you to go ahead and create an EER diagram from it, and then submit that so that I can see the new structure. But obviously something is going wonky here, which what I expected to happen was I expected to see a couple foreign keys here, and not just one. Primary, okay, so the primary is referencing both, but user's ID, hang on a second, maybe this just isn't tall enough. No, that's not it. Yeah, I expected to see the one-to-many going here and here, and I don't know why it didn't work. All right, well, that happens sometimes. Let's go ahead and just call it into that part of the demo. I'm going to have to look here and see if I did something wrong with the way I set up these tables. Unfortunately, as you guys know, you can't really go into the inspector and check on the foreign keys. I mean, you can look at indexes, and yeah, see, it only says users ID. What did I do wrong? Let me check my script file here real quick. Books ID. Yeah, this should be both of them. Hmm. Hang on a second. You guys don't need to do this. I'm just going to try this real quick. Let's see, what happens if I get rid of these last two columns here? Well, I'll copy and paste. Hang on, folks. If I can't figure it out pretty quick, we'll just move on. Promise. Let's see, so I'm going to just go with what my original thought was. Instead of turning these into a primary key or unique, it really should be unique though. What happens if I just do unique? And then let's check out users books again. Go away. I'm still only showing the one key. What am I doing wrong? Okay, extra credit. Anyone who can figure it out before me? Get rid of that. Let me get rid of the unique value too. Maybe that's what's messing it up here. User ID, books ID. Where's this? That doesn't show any of them. The foreign keys, I was saying, like this part never works here in the local instance. If I try refreshing, it gives me an error message. Oh, it doesn't this time, but usually it does. All right, I'm gonna try one more thing, and if it doesn't work, we will move on. I'm gonna go ahead and do the I'm gonna do the whole thing here. I don't know what's going on here. Because this is the way that I usually do it, but users key, users ID, references, users ID, and then another one just like it, constraint, users books, books, foreign key on books ID, references.
We're still not doing this, right? Or are we doing this?
Yeah, no, let me try this out first. Okay. And I will get rid of the extra column at the same time just to make double sure. Okay, if it doesn't do it this time, then it's just flat out refusing to do what I tell it to, because this absolutely should work. All right, let's try. All right, let's see. First this. There's the columns. Okay. Wow. It actually did a couple now. Okay, so, you know, that shorthand, the inline, there shouldn't be a problem with that, as far as I know. But I can no longer recommend its use because now when I do it this way, it seems to work. But let me check on one more thing. I'm going to close this diagram, and I'm going to try turning it into another EER diagram here. So plot from database. This will only take a second. Oh, boo. Go. All right, that seemed to work. So obviously there's something wrong with that inline script that I was doing. It's not one that I normally do, so I must be doing something wrong. I can't think of what it would be, but I'll get it figured out. So use the explicit syntax. Use this guy right here. So I'm just going to take this script. You guys do not need to do this for the demo right now because that would be asking a bit much. But I will make sure that this script is available to you. You can take a screenshot of it right now if you want to. But this is, obviously this works and the other one, for some reason, did not. So we can always add another column to this. So that's what I'm going to do here. I'm just going to alter table, and this is users books, and add column, and it's going to be user rating, and it's going to be decimal, 2 and 1, and let's just go ahead and leave it at that while I'm only so far behind. No, actually, let's do the select all here. Okay, so there it is. We got the user's ID, book's ID. Those are the two foreign keys, and it has now added a user rating. So my apologies for the mix-up there. Like I said, I'm surprised. I thought that would work. But apparently this one is not doing what I wanted it to. So I did the explicit syntax, and I left off the primary key and the unique, which makes me shudder because they really should be unique, but I'm just going to leave it like this for now. And then once I'm not on the recording, I'll try adding in that other stuff in slowly, one piece at a time, and see if I can figure out where it broke. So, any questions other than like WTH, man? I hate it when that happens in demo. I should have known better than to flip over to some a scripting style that I don't normally do. Okay, so this is what you want to do then. The whole package, do it this way. Good. Let's get past this now because that was a bit rough. I'm going to go ahead and stop the recording. And I'm going to do, let's see, I told you guys we had quite a bit to do here. It's 8:51. I think we still have a bit of time. I know I'm not giving you guys like any lab time tonight, so sorry about that. Let's do a little bit more. And then we'll go ahead and I'll let you guys cut out a little bit early because you're big troopers here. So give me just a heartbeat. I'm going to stop the share here real quick. Hey, Chris. Yay, I think we actually have everybody here. Cool.